In this video, we will be looking at question related to vector. Before we begin, please hit the subscribe button, comment and like the video to show your support. We have here the question: a particle undergoes the following consecutive displacement: 3.5 meter south, 8.2 meter northeast, and 15 meter west. Question number 1. Sketch the vector diagram of the displacements. Question number 2. Determine the resultant displacement of the particle. For reference, I will be drawing the directions at the top right of this slide. So we have north direction, we have south, we have west and east. For each of these four directions, the angle will be 90 degrees to one another. We also have additional 8 direction, which is exactly in between of these initial 4 direction. For example, this is in the direction of northeastward direction, so the angle from east is going to be 45 degrees. Same goes to the direction from north, which is also going to be 45 degrees. Moving on, we also have northwest, southwest, and last but not least, southeast. Now we will be sketching the vector diagram of the displacement. So for reference, I will be drawing the x and y axis. First of all, it will be 3.5 meter south. So south is downward direction or negative y direction, having a magnitude of 3.5. So let's assume the length here will be 3.5. So this is going to be represented by the first path taken by this particle. Moving on, we have the second path, which is 8.2 meter northeast. So northeast is 45 degrees upward direction from east. For reference, this is going to be the line, horizontal line, parallel to the x-axis, which is pointing toward eastward direction. Since it is 8.2 meter northeast, the length is going to be a bit more longer. So this is going to be 8.2 meter northeast, and last but not least is going to be the third path, 15 meter west. Westward direction is to the left or towards the negative x direction. So this is going to be the third path. Moving on, the second question asks you to determine the resultant displacement of the particle. The displacement is going to be the shortest distance from the origin or its initial position to the final position. So this is going to be our resultant displacement, which is represented by this green arrow, and we can write it as the vector for r. The three paths can also be represented by vectors. So let's assume the first one here is going to be vector A. Second one will be vector B. The third one will be vector C. So in the end, in order to obtain vector r, or to eventually arrive at the final position, we can see that r is going to be equal to a plus b plus with c. So now it is important to convert this information into vectors. For the first one, vector a, because it is 3.5 meters south or 3.5 in the negative y direction, it is going to be equal to negative 3.5 g. And moving on to vector b, as you can see here, we have two components, which is component x and y. It will have bxi plus with byg. We can write down the magnitude, which is 8.20 cos 45 degrees I, and then plus with 8.20 sine 45 degrees g. So I will continue for vector b. If we calculate the value of 8.2 cos 45, it is going to be equal to 5.8 I, and then plus with 5.8 g. Last but not least is going to be vector c. So for vector c, it is 15 meter west, which is towards the negative x direction, so it is going to be negative 15 I. So what we have to do next is substitute the numerical value for each of the vectors. So for vector A, it is negative 3.5 g, and vector B will be 5.8 I plus with 5.8 g plus with vector C, which is negative 15 I. So remember that whenever you want to add vectors, you have to add according to the component. So we only need to add of the same component, which is 5.8 I plus with negative 15 I, and then 3.5 g with positive 5.8 g. The answer will be vector r is going to be equal to negative 9.2 I, and then plus with 2.3 g. So this is going to be the resultant displacement vector of the particle. So to find the resultant displacement in terms of magnitude and direction, firstly what we have to do is apply Pythagoras theorem. So r, we put it in the modulus form where we want only the magnitude. So it is going to be negative 9.2, the x component, square plus with 2.3 square. So the answer will be 9.48 meter. So this is the magnitude, and then moving on for the angle, we can use this function. Theta is equal to arctangent the y component over the x component. So theta is going to be equal to, the y component is going to be 2.3 over 9.2, negative 9.2. So theta will be equal to as we calculated, it is going to be negative 14.04 degrees. But this is not the correct angle because negative 14 here is actually from the negative y-axis. Right? So this is actually the negative 14.04 degrees. Where we should actually report our angle from the positive x-axis. So eventually theta should be 180 degrees minus with 14.04 degrees. So theta is going to be equal to 165.96 degrees. So this is the magnitude, and then this is going to be the direction in the form of angle from the positive x-axis.